The broadcast is now starting. All attendees are in listen-only mode.
Well, hello, everybody. Welcome to Coffee with Caleffi. Well, here we are, December 2015. We all made it, so thanks for joining us today. We've got a great crowd. I'm going to talk about proper component selection for renewable hydronics, and this happens to be one of my favorite topics, and I could talk about this until the cows come home, but I won't today anyways. But I'm glad to talk to anybody about this topic, so if you have questions on a job or something that you're working on or have some information you want to share with us, I'd love talking about this. So we'll go through a couple different topics concerning renewable here. Caleffi Hydronics, up to issue number 17. A lot of the slides that I'm going to show you today, a lot of the piping diagrams and stuff like that will come out of one of our hydronics issues. Interesting about this topic is that it's all hydronic related. You know, when we talk about renewable energy, the common thread there is hydronic. So whether it be a balancing valve or a zone valve or an air separator or something like that, all of our components work on renewable energy systems. So I'm going to focus in on a couple of them that we did specific to renewable, the solar ones, the geo ones. So I'll show you the issues as that comes up. All right, renewable. What's a good definition of renewable? I mean, everybody has a different, I think, idea in mind what's renewable. To me, really, it's energy that's either generated or transferred from a renewable source, a natural resource. It's constantly and sustainably replenished. It's a very large supply, especially when we talk about solar. And when we talk about solar, every second, the amount of energy that comes from the sun is enough to provide 500,000 years of our current needs of civilization. So there's a big, large energy source up there. We just have to figure out ways to tap into it, to do it properly, to do it affordably and stuff like that. So the topics I want to cover today here are thermal, solar thermal. Obviously there's solar PV, electric side of it. We're going to be focusing on the thermal side of it. That's the arena that Caleffi plays in. And when I talk about thermal, that can be for domestic water loads or for heating loads or maybe process loads in a factory or something like that if you have some needs for hot water. We'll talk about geo. Geo for me is like loop fields. It could be pipes down a well. It could be a trench system. It could be some loops in a pond or something like that. We've got components we'll show you for that and give you some ideas. And then another one would be wood, biomass. Certainly a lot of remote areas, rural areas, people are still heating with wood. They have wood-fired boilers or pellet-fired boilers. So we'll show you some ways that you can pipe that. You can integrate it with other systems. So those are our three go-to today, and that should be plenty to talk about. I'll start with solar thermal. This is one of my favorite. I've played around in this technology since I've had a building. I've had this solar thermal in all my houses. I've got 4 different systems going now, and I'm still learning. So I want to see what you guys are doing. I know when we get the Caleffi Excellence entries in, we've had quite a few on solar, and I'd like to see how you guys are putting those systems together and integrating them with your boilers and hydronics. So send those along. But really, what you want to find with solar thermal is a consistent load. You know, it doesn't work so well when you've got a load that's big one day and small the other day. You can come in overheating and issues like that. So look for a consistent load, and I put up some of my my favorite ones. I think these are sweet spot jobs right here. Brew pubs, little breweries. I mean, they use an X amount of water every day for their brewing and for their cleanup and stuff like that. It's a nice thing for them to show off. A lot of the breweries like to show that they're being energy conscious. So it kind of works that people are attracted to solar beer, so to speak. And we've been involved in quite a few of those. Certainly in the Milwaukee area, we've been helping people that have these microbreweries and small breweries with solar thermal. Another one is bottling facilities. I think one of the most efficient systems that's ever been put together in the U.S. is a bottling facility down outside of Phoenix, Arizona, in Tempe for Coca-Cola. A real low load temperature, so they get real high efficiency out of their collectors there. Water parks is another good one. A lot of domestic water demand there for showers and stuff like that. If there's a restaurant, certainly there's a load there. But also just keeping all the pools, inside and outside pools and wave pools or whatever. So there's a big consistent load there. Another one I put on there that one of our contractors over in Indiana has done a few of these is correctional facilities, prisons, constant loads there. They seem to all be full or overcrowded, so that's a load that doesn't go away. And these are jobs where the economics can still work out. With energy costs really low right now, residentially speaking, a homeowner looks at this and says, gosh, the payback might be a little far down the road, and that's driven a lot of times that decision is driven by energy cost as well as any kind of rebates and stuff. But until the energy price comes up a little bit, I think that residential market's going to be a soft. But there's these big ones are good jobs, and we've got contractors that specialize in this market. This one picture down here in the lower left is one of our contractors over in Indiana, Man Plumbing and Solar over there, and they do a lot of some of the prisons that they've done. They also do schools and stuff like that, and they kind of like these big jobs where they can go in and really make a big dent in the energy cost for a building. And an example of one of the brew pubs over here. Interesting, in the Clean Energy magazine last month, they talk about the breweries are going a step further, and they're actually starting to put some anaerobic digesters on a couple of these. There's actually 3 projects in the U.S. right now where they're taking energy out of that waste, you know, the mash and the grain and stuff. They can turn that into methane gas and run some of theirs. So they're looking at maybe another 40% reduction in energy costs by using some of the waste from that. I thought that was pretty interesting. So solar components, a couple things unique about solar is that we're going to be operating at much higher temperatures than we typically do in a hydronic system, a residential hydronic system. We're typically talking under 180 degree operating conditions and operating temperatures. So when we look at solar, certainly when we go into stagnation conditions where the pump might go out or the load is satisfied, we've got a collector sitting up on the roof, and we can see in excess of 350 degree temperatures up there. So it's important that all the components that we have in that piping circuit can withstand that kind of temperature. So if the pump kicks on and we get a surge of that 300+ degree water coming down to our air vents or our relief valves and different components in the system, we want to make sure that we've got a product that was built specifically for that. So what we have from Caleffi here, anything that's chrome plated like this, it'll say Caleffi Solar on it, and it is built of different components inside here. We use different makeup of the parts in here so we can operate at those high temperatures. If you look through our price book and our spec sheets, typically you're going to see a 320, sometimes up to as high as 360 F operating conditions. So if you want to build your own systems and buy a la carte parts like vents or relief valves, certainly we can help you with that. Probably one of the best products that has come out on the market, and we offer a really nice pumping station here. This is our solar pumping station. And the beauty of this is it has all the components under the hood that you need. They're the right components. They're rated for the temperature. They're rated for the flow rates. It has all the gauges you need. It has the safety group up here. So you've got your pressure gauge. You've got temperature gauges, supply and return, so you can make sure that you're getting performance out of your array, that everything's working properly. We've got fill and purge valves down here on the lower right-hand side. Of course, this insulation jacket encloses everything when you're in there. We can give you different adapters for this. You can use our SolarFlex pre-insulated tubing for that, or if you prefer to pipe your systems with hard copper or something like that, we can give you adapters for that. So this is a plug-and-play unit. It's got a multiple speed pump in here. It's got a flow meter so you can dial in exactly what you need. Really, you take this thing out of the box, make your connections on the top here up to your collector array, and then on the bottom down to your storage tank or to one of the solar Caleffi tanks here, and plug it in and dial in your settings, and away you go. So that's made it really easy for guys that are just beginning in solar. If you haven't done a solar system and say, I've always been intrigued by that, I want to give it a try, I'm a little intimidated about what parts I need to do it, we've got a solution right here in this prepackaged solar pump station. We also have a drain back version of that, and we have a single pump station, so if you're doing an east and west array, we can loop 2 of these together and help you with that. Air vents over here, again, a high temperature air vent. Solar tanks, we have a couple different versions of this here. It has the heat exchanger built right into it. These 2 connections right here are heat exchanger, dual anode rod, a nicely jacketed, nicely insulated tank. Also has a backup element inside of it there. We've got these available in 50, 80, and 120 gallon versions. And we do have some dual coil versions. I'll show you some applications for that as we go. And then over here, the iSolar controller. We've got a few different versions of this, a basic 2-output one, and then we've got some more advanced ones for guys that want to tie in some heating circuits or something like that. We've got some with up to 5 inputs, so we'll show you some of the controls and what they can do as we look at some of the schematics as we go through here. The other thing that we did is when we got into the solar business back in about 07, 08, we said, we need to come out with something unique and different that would help everybody put these systems together. The tax credits were good then, the energy costs were high enough that this was a big market. So we said, we need to put everything in a box so that when somebody orders a packaged system from us, it arrives in this crate that you see over here on the right, and it has all the parts that you need to put it into the system and put it into operation. So in the picture here, we give you that pump station that we just talked about. The expansion tank is sized properly for the number of collectors that you get in the box. The tubing with the wire, everything's in here, all the hardware, all the mounting brackets. We even give you some premixed glycol, 50% premixed glycol. So put all the pieces together, connect all the dots, so to speak, put your glycol in this, plug in the controller, and away you go. The controller's even pre-programmed, so you could take it out of the box, make a couple wiring connections, and plug it in, and you're up and going. We have different versions of this package here, different amount of collectors, single collector all the way up to 3 collectors. We can customize it a little bit for you. If you want a larger array for a little bit higher energy offset, we can give you more collectors, different size collectors. The goal with this package system right here is we wanted to put it in the crate that would fit in a typical box truck, make it easy for you to get it out to the job site, makes it easier for the wholesalers to handle them and stuff like that. So take a look at what we offer in our price book and in different packages. And here's probably the most basic way that you would put in a solar domestic residential system probably. So here we've got the collector, the pump station, and in this case we've got a single tank. So what we have to do if we're going to use just a single tank application, we've got to give you a backup source, because there's going to be days that you don't have enough sun to cover the load completely or sun at all to cover any load. So in this tank here, you can see halfway up the tank we put a 4,500 watt element in there, just a typical electric water heater, 240 volt. 4,500 watts. So if you don't have enough energy from the sun, then this element would kick on, and it would take the tank up to the final temperature or heat the this portion of the tank if you don't have any solar input. Just know with this system here that if you're going to run this element, you kind of reduce the amount of harvest you can get from the sun, because you're maintaining the top half of this tank, as you can see by the red color, is warm. So now when the solar comes on, it's really looking at the bottom portion of this tank. Now there's things you can do to kind of fool that a little bit. What some people do is they'll put a timer on this element, and they'll say, well, I'm going to leave the element off until 4 o'clock in the afternoon. That way I've got all day to recover my tank with solar, and by the time I get home from work and I want to take a shower and there wasn't enough solar energy, that element would automatically kick on at 4 o'clock, and it would make sure that you had enough temperature in your tank to do that. So this is nice when you have a limited amount of space. Maybe you're doing an apartment or condo or something like that. You've got to take out the water heater that's in there. You've only got room for a single tank in there. This is a dual purpose tank in that you've got the electric backup as well as the solar input. So a fairly common way of doing it. I prefer this one here. This is what we call the 2-tank method. So basically what we're going to do here is we're going to do the solar preheat on this tank here. So the cold water comes in from your city supply main or your well supply here. It comes into this tank. And this tank will take it sometimes up to the 140 degrees or whatever you set your control at, and then it just feeds out of this tank into the second tank here and then into the system. So if you've got enough energy to recover this tank, it's just going to feed through and go right to your system. This tank here won't fire up the second tank or the backup tank, if you'd call it that. There's no need for that to fire up. That could be electric, it could be gas fired. So this gives you quite a bit more energy harvest, because you're going to have a cold tank here every morning. If somebody's used water during the evening hours, this tank will be filled with cold water when the sun comes up. Now we're looking at this entire tank as our load, so you're going to get a little bit better return on investment if you can have a tank dedicated right to the solar, feed through the second one. Again, this is part of our package system here. What's really important on these when you do your systems is you have a good thermostatic mixing valve here, because there's instances where this tank might go over 140 degrees, 150, 160, whatever you really program in the controller is what this tank is going to go up to. So we certainly don't want to take that 140, 160 degree water into the secondary tank and right out to the load. So we want to have a good thermostatic mixing valve here, and of course, Caleffi, we've got some choices. We've got a solar rated one for that. If you've got a larger commercial job, we've got larger sizes for that too. So that's an important component. Don't forget that. You wouldn't want to put that on that tank here. Some people say, well, if I put it right here, then I'm going to protect the water going into this tank from the solar. But if this tank ever overshot its temperature, now you've got the protection right here that it's going to protect both these tanks regardless of what temperature they go up to. So that isn't included in our kit. If you want that thermostatic mixing valve, you're going to have to tell us, what you need as far as the size of it, what piping connections you might want to use on that, because we can give you, sweat, we can give you threaded, now we can give you press fittings for that. So make sure that you put that in the system, and that's the importance of that. Now this is probably going to be another typical one. If the job has a boiler already on site, it might have an indirect tank connected to that boiler. So essentially we're doing the same thing here. Is we're preheating. We're going to take that temperature from the first tank, feed it right into the indirect tank, and now the boiler is going to give it its final boost, or it's going to cover the load if there wasn't any solar at all for some days. So instead of depending on an electric element or a secondary heat source here, we're just going to use an existing boiler to do our input. So same components here. Again, this is part of the package here. Everything you see in this grade box will come in the package, and you would make the connection here. There's another thermostatic mixing valve that we want to show there. And of course, this could be a dual purpose. You know, if this boiler is doing the heating loads in the building, you could add an indirect tank onto it. It's a nice way to do domestic water because you're using the efficiency of this device here, this boiler, to make your domestic water load. So if you've got a high efficiency boiler like a ModCon, you're going to have a really good efficiency rating on that system. Now this is another tank that we offer. This is what I talked about is a dual coil version, and this is available in the 80 and the 120 sizes. It's not available in the 50. There's not enough room in the tank to get that second coil in there. So this dual coil tank can be used in a bunch of different ways, and here's an example where now we've got a boiler that's in this house is going to feed right into it. So now we're back to a single tank configuration here. Again, maybe we've got a space requirement that we've only got room for a single tank. We can use that as our solar input tank on the bottom coil, and then we'll use the upper coil here as our secondary input from a boiler. It could be a geo heat pump, it could be a wood boiler, it really doesn't matter, but it's just giving you the ability to put the load right into the one tank, second input into the one tank. I want to talk about this one a little bit more because another option for this upper coil is you could take heat out of this tank. So just think of these SolarCon tanks as heat exchangers. That's really at the end of the day what they are. So we're going to do multiple things. We're going to store our domestic water in the tank. The volume of the tank is going to be our domestic water. We're going to have our input, our heat exchanger from the solar, because if you think about it, this and this are exactly the same thing. They're both heat exchangers. One's taking the energy from the sun, putting it in the coil, in the tank, and then this coil here could be used to take energy out. So you might run a small radiant loop off of that. You know, you can just put a pump on here and go out to a small loop and take some energy out of the tank. So now you've got your domestic water and you've got your energy out. You would need a backup source or have the element. In our 120 version, we do offer the element that goes right in here between the two coils that are inside the tank. We've got the heating element, so you can use it as a triple function. Now you've got your domestic water, you've got your two coils as well as your resistant element as your backup. I want to kind of show you what's under the hood of these. This is a really nicely built and engineered tank. We well insulate it. We've got 2 inches of spray foam, so this tank is insulated across the top, across the bottom, and it's injected all around it. So there's no leaks from the insulation there. It has a nice insulated shell all around it, so it can be used for, you know, cold water doesn't sweat on the connections and stuff like that. It also has a powder-coated metal jacket, and that's nice. So if you want to mount your controller, if you want to mount your pump station right on the side of this, you can just put a couple of zip screws in there. It's powder-coated. It's a heavy-gauge metal tank. It does have dual anode rods that go in it to protect that tank, make sure it lasts a long time. This is where the resistance element would be in it. Here's kind of a cutaway of a little drain back tank that I was working on, and you can kind of see the dual coils in there. They're large diameter coils. They're 1.5 inch diameter coils, OD diameter coils, so we can get a good flow rate through that. Some guys will take the dual coils and they'll just series them together. So if you want a high input or a high output out of that tank, you can just connect this coil to the upper coil, and now you double up your coil capacity. We've got about 36 feet of coil on the bottom, a little bit shorter on the top one. That's about 30 feet of coil, so a lot of heat exchange surface in there. And that's especially important on solar because we're talking about some low temperatures here. So the more surface area, the more coil we have in the tank, the better performance you're going to get out of that tank. So we go with a good glass line tank, so it's good for any kind of water conditions. We did 2 different issues on solar thermal. Hydronics number 3 a few years back. That kind of was the basics, introduced you to how solar thermal works. We took you through some of the formulas, some of the sizing information of that. And then the guys got a little bit used to that and said, well, you know, what can we do for some other loads off of the solar thermal system? So we came out with issue number 6, which is combi systems. And you can tell in the picture here, we showed you how to tie that into maybe a pool load or some radiant heat or something like that. So it was kind of a little bit more advanced piping and advanced version of the Hydronics number 3 is the number 6. So some of the drawings I just showed you come out of those 2 Hydronics issues. As far as incentives that are available right now, this is a website you can go to, the government website. They keep this pretty fresh. Usually every 2 weeks they go in there and update this. So you go to this website up here and you can just click on your state and it's going to give you an idea of some of the different programs that are available. So if you went to Wisconsin right now, I think I might have put a screenshot of Wisconsin in here, maybe not. I think there's quite a few programs. There'll be not only what's available from the federal government. We got good news yesterday. We think that the ITC tax credit's going to get renewed. Of course, you never know with Washington until the ink's dry in the thing, but from what we heard yesterday on some of the information from the CIA, which is our trade association that does our lobbying for us, it looks like that's going to get extended. Right now it does go until the end of 2016, so you've got a year to get your systems in and get that credit, but we're hoping that'll be extended. But this site would show you all the different ones. The federal tax credit, it'll show you different state incentive programs that might be out there. If your different utility companies have rebate programs or incentives, this is the place to go. You can put your zip code here and it'll drill it in a little bit tighter than just clicking on the map. That'll give you all the different state programs. So use that information if you're going out there. It can sometimes help you sell a job if the homeowner, the people that you're bidding it to can see that there's a little bit of a financial help out there. And this example of a New York State right now seems to be at the forefront of the biomass, and they've got some programs going right now. They've got programs that they're trying to replace some of the older outdoor wood furnace with higher efficiency equipment, and you can get up to $7,000 towards a project like that. So they're really doing a lot to push the renewables, and certainly with biomass, there's a lot of that fuel source up in New York and stuff. So John Siegenthaler works with them. He's developed a course for them that you can, he's presenting at a couple different locations, usually 4 times a year you can go, and that gives you some of your credits. If you're an engineer or a contractor and need to get your CEU credits, this does qualify for that. So if this is something that interests you, by all means, check into what NYSERDA is doing over there in New York State. Biomass, we did an issue on biomass. For biomass, for me, means like wood. It could be wood chips, it could be pellets, it could be shavings and stuff like that. It's typically going to be something that we combust, that we burn. We do make components specific to that, and you can see on the Hydronics cover, we always try and show you some of the components that we have for that. Let's talk about biomass and what some of the options are. Cordwood, I know when I go over to Europe and all the remote areas outside of the cities, a lot of people are still heating with cordwood. And over there, they've got energy emission standards. So if you're going to burn wood, you have to use one of these high efficiency wood burners over there. These are called gasification boilers, where we burn the wood in the upper chamber. We take those flue gas products and we take it down to a ceramic lower chamber, burn them a second time. So that puts us up into the low to mid 80 efficiency ranges. Chips, these are typically larger boilers where you're going to have something more like this photo down here where they auger in these chips. The nice thing about chips as opposed to pellets is that it doesn't have to go through one more manufacturing process to get it there. When we make pellets, we know we got to dry the sawdust, we have to compress it, we have to do a little bit more to it. So simplest way is just take the wood right from the fallen trees, split it up, burn it that way. Chips would be the next thing, where if you can go to a planer mill or some of the sawmills will make chips or sawdust available, and then they can squeeze it into pellets. We actually visited a pellet mill with the RPA a couple of years back up in Utica, New York, and got to watch the whole process from the trucks backing in and dumping the sawdust from the planer mills and stuff like that. They took it in these big tumble dryers, they dried it, and then they have these big presses, and it looks almost like rabbit pellets, you can see in the picture here. The nice thing about a pellet boiler, a pellet burner, is that we can control the burn rate. With wood boiler, you're kind of, put in the cordwood and you adjust the burn rate by the amount of wood you put in there. But with pellets, we've got a variable speed auger, like down on this Evo product here that comes out of Troy, New York. There's an auger in here with a variable speed, and it'll just pull the pellets out of your storage container, and you can just dribble them in there, you can feed them in fast. So we can kind of match the output of that boiler a little bit closer to the load than we can with a cordwood boiler, where you kind of have to go and manually adjust your burn and depend on that for your output rate. Pellets, there's a kind of a formula right there. It depends. They make them out of different types of wood, hardwood, softwood, or blends of wood. But about 17 pounds is going to equal about what you'd get out of a gallon of fuel oil. So that kind of gives you an idea of what you can expect from a bag of pellets as far as the energy. There's other products that they're compressing in the logs or bricks that are out there. In fact, we went to one of the renewable energy shows a couple years ago in upstate New York, and there was a company there that was compressing horse manure and some of the bedding from around the horses into bio bricks, they called it, that you could burn. You know, you just light them off and burn them in your fireplace or your wood stove and something like that. Coal, I don't know that I'd officially call that a biomass product, but certainly where I live, the Amish are still burning coal in their wood-fired boilers and fireplace and stuff like that. And there's a lot of choices. I think every year we see more availability. Froling is one of the companies that's offering both cordwood and pellet burners. Froling, Windhoggler, this is the EKO, this is the brand I have in my own house. Larger companies, this is a company down in Alabama that makes big chip and pellet burners for commercial applications. And Evil World's another company that's actually manufacturing this under a license from an Austrian company making these pellet burners and cordwood burners and all the components, the tanks and stuff down in Troy, New York. Buffer tanks. Now, a buffer tank is something that can work in all these different technologies. And really what we're doing here is think of it as a thermos bottle. So if we're going to store our energy, we want to keep it in a well-insulated vessel so we don't lose so much of that heat energy. So a buffer tank is what we call that. It can be piped into the geosystems. It could go into the solar system. It could be tied to a biomass boiler. What it's going to allow you to do is get longer, more efficient burns. So what we want to do, especially when we start a cordwood boiler, is we want to burn that long and hot. It's going to be most efficient when it's burning at a good output temperature, so we're getting good gasification. So if you don't have a load that's using that energy as fast as you're creating it from the boiler, we want to park it somewhere, and that's what we do with a buffer tank. And the other side of a buffer tank, it gives you coast time. So once we get this tank up to temperature, now we can go for maybe a couple hours or maybe even overnight just using the energy out of this well-insulated tank before we have to start another fire. So there's formulas that we give you in both the Hydronics issue on how large this needs to be. And again, it's going to depend on how long of a burn you're going to have and how much coast time you want to have out of that tank once the fire is out. This is the same tank that we use for our solar con, our thermal con. It doesn't have the coil in it, but inside it's a glass-lined tank, so it can be used for domestic water. You can drop the dual anode rods, the tappings are in the top. If you want to use it for domestic hot water, drop a couple anode rods in there. The main thing that we did with the thermal con is we give you a lot of connections. So we've got actually 7 connections around the side of this tank, 2-inch connections. So if you want to use a high flow rate application, you've got connections at the top, you've got connections at the bottom. We even give you midpoint connections, so if you want to go in and just kind of access to this stratified layer up here, you can get in out at the top. Connections up here at the very top, 3/4, 1-inch connections depending on the size of the tank for domestic water loads. A nice brass drain cock at the bottom. The size that we have available right now, we've got a 25-gallon stubby. It's a short version of this, and what's nice about that, if you want to put that in the closet with a wall-hung boiler mounted above it, now you've got a short stubby version that you can, with a small footprint, you can get your boiler and your storage buffer tank into one room. 50-gallon, 80-gallon, also 120-gallon available with the thermocon tank. Here's an example. This is Heatmeister, our friend out in Dillon, Colorado, and he put this, you can see exactly what I was talking about. There's a little ModCon boiler mounted right above the stubby buffer tank here. And what he used this tank here is a buffer tank for a system that had an old non-barrier tubing. I think it was a polybutylene system in the radiant, and they were having problems with the, the corrosion stuff in that system. So he went in there and he put bronze pumps and he kind of flushed that system out and put it back in service. And then he went back a year later just to see what the anode rods in this tank were doing. And so we're using the sacrificial anode rods to protect with some of the oxygen ingress that's still getting in through that barrier tubing. So that was interesting for me to see that he was using the anode rods in a closed-loop hydronic system just, again, to protect from the oxygen that's getting through the wall of that old radiant tubing there. And he's happy about it, too. Thanks, Richard. I want to show you something here on piping a buffer tank. This is something that's come to our attention recently that they started doing over in Europe. Really, the Austrians are kind of leading the charge on some of this biomass piping, and they seem to be the most up to date as far as different ways to pipe these systems. And what we learned from them is this 2-pipe buffer tank configuration. So let me start over here with the 4-pipe. This is typically what we've been showing in some of our hydronics and some of our piping schematics, is where you use this tank as both a buffer tank and as a hydraulic separator. So to do that, you just use all 4 connections like that. So we're coming in from our heat source on one side, returning back to it. There's our primary, secondary, so to speak, our hydraulic separation. And then we're taking our heating loads off the other side. And this is still doable, and this works pretty good. But one thing that happens with this, as your flow rate changes, either on the input side or in the output side, you start mixing the temperature that's inside here. And what we really want to do is stratify this tank. We want to keep our hot temperature up to the high point. We want to keep our cold returns at the bottom. This is going to go to our heat source, and that'll keep the efficiency of the heat source up if we can keep those temperatures low. But as we start changing the flow rates on the A or B side, we start breaking up this thermocline and this the way this tank is stratifying. So what we found is there's another way with a two-pipe connection, which of course you can still do with the thermocon. You don't have to use all 4 connections. But if you look at what's going on here, we're coming in from our heat source, returning back to our heat source here. But now we're taking our load off outside the tank at this little detail right here. And this becomes our hydraulic separation. So as long as we pipe this large enough to handle the flow from the heat source coming in and loads going out, this is actually where we've got our hydraulic separation. Instead of having it go on inside the tank like we do with the 4-port, now we've got it going on outside here. And that's going to do a couple things for us. So now as we have a load comes on out here and the boiler kicks on, or the wood boiler, whatever you've got connected here, we've got the ability to take that energy directly out to the load without going through the tank first. So instead of having to go across this layer, keeping that portion of the tank warm before we get out to the other side in this 4-port piping configuration, now we're going to take our heat source directly to the load. And let's say the load and the heat source are exactly the same flow rate, 10 gallons per minute. Nothing's going to go in or through this tank here. 10 gallons a minute would go right out to the load. Let's say that load's got a variable speed pump on it, or it's got zone valves that start shutting off. The load starts going down as far as the flow rate required. Now we're going to start seeing that flow going through the tank. So here we've got 10 gallons a minute coming in from our heat source. We've got a fixed speed pump, let's say there. We've got 8 gallons going out to our load, so now 2 gallons a minute is going to go down through the tank. So you can see the difference here. With that 2 gallon a minute flow rate going through there, we're not going to start breaking up our thermocline like over in this picture here. If we're going through as a 4-port connection, now we've got 8 gallons a minute coming through the bottom of the tank. That's going to stir up that tank more. So what will happen with this 2-pipe configuration, we'll cover that load, and let's say this load goes away completely. All the zone valves shut off, all the pumps shut off. Now we're going to start loading up our buffer tank. And let's say over the course of a couple hours, we get our tank loaded up to, let's say, 160 degrees. The boiler kicks on. Now when the load comes back on, the boiler doesn't have to kick on because we're going to have the ability to pull the energy out of this tank first, and we'll take that down to whatever the low limit that we set on this tank before the boiler has to kick on. So just by using this detail here with this 2-pipe configuration, we decouple our boiler from our load and from our buffer tank, but we can pull out of the buffer tank without going through the boiler, or we can go directly from the boiler to the load. So take a look at that. Hydronics number 17, we talked quite a bit about these 2 different piping configurations, why you would use one over the other, but really that's the key to it, is this here. And the thermocon tank is ideally suited for that because we're giving you 2-inch connections here, so you've got the ability to build this little hydro separator on here, because you can start out with a 2-inch nipple, use a couple reducing tees here to get down to whatever size you need for your load going in, your load going out. So we've got the perfect application with our thermocon tank to do either one of these piping configurations. And this is exactly what I was talking about. You can see when the tank is at rest, we're going to thermal load this tank. This is called a thermocline. We want the hot water to rise up to the bottom. This tank can vary from top to bottom as much as 10, 15, sometimes 20 degrees. So there's our high temperature at the top of the tank stacked in there, our cold temperature at the bottom. And then again, as we start flowing through there, you can see with the heat source coming in now, how we start driving that thermocline down. We start loading this tank from top to bottom. And then over here, let me move my little toolbar out of the way. You can see as we start the flow starts going out to the load. Now we start using up the high temperature air, the cold's coming back from it, and we start moving that thermocline up. When this boiler kicks on now, it's got access to all this cold temperature. That's going to drive up the efficiency of the boiler. So it's a pretty unique way, the way these tanks, how this temperature gradient, this thermocline moves up and down as you flow in and out of the tank with your loads and your inputs. A couple little tips about tanks when you pipe into them. You don't want to go on the top like that where the flow would come in and would have this turbulent flow, because that's going to start breaking up your thermocline that we want to maintain over on the far right here. We want that tank to stack. So if you go into the top like that and you've got flow going down there, you're going to mix that tank. You're going to blend that whole thing up to one temperature. We really want to load this tank. We're going to store more energy if we can load this tank with a high temperature at the top. and a low temperature at the bottom. We've got more usable temperature in this tank than we do here, because if you look at the picture, let's say that the red is 140 degrees. These tanks, pink, let's call that 120 degrees. We've got a lot more energy stored in this tank when we can stratify it like that. I learned about this company at one of the trade shows that I went over to Europe, and they did an interesting thing. When they go into the side of the tank, the engineer there said, no, you never go in the top of the bottom of the tank for this very reason. He said the only way you would ever do that if you had some kind of flow diffuser down at the top, so when that water comes in, it just kind of layers it up like that. So what they do is they always go in the side of the tank, and they make these little nipples with, I can see kind of an arc in it. So this nipple actually comes in, and it arcs up to the top of the tank. So they make sure when they use a side connection like that, that they're going to get the flow all the way up to the very top and the very bottom of the tank. And this Swiss company makes tanks of all different sizes. There's one going up to a job on the top of a mountain that's being hauled up under a tram there. And we do on the thermocon tanks, we have those side connections, so you can go right in the side here, and you don't have to be concerned about breaking up your stratification with a top and bottom port. Now here's an example of a pellet-fired boiler. This could be a cordwood-fired boiler. Critical to these boilers is you have to have return temperature protection, and that is to say that we don't want cold water coming back to this below whatever the flue gas, the dew point of this temperature of the flue gas is, that we start creosoting up these boilers. So we make two different products for watching and maintaining that return temperature protection. One is called our monoblock here, the 281 series. This has a pump built into it. So what you have in here is a little thermostatic cartridge. It's non-adjustable. You can buy different temperature cartridges from us, but that little cartridge in the bottom just watches the temperature coming out of the boiler, the return temperature coming back, and it's going to make sure that this temperature is maintained at, let's say, about the 140 degrees sensor in that. It's going to make sure that this temperature going back to the boiler is always at that 140 degrees. So basically what it's going to do is it's going to take the hot water coming out of the boiler, blend it down this bypass line here, and it's go right back to the boiler until that thermostatic cartridge says, yep, I'm warm enough going back to the boiler. I'm going to let you start going out to the load. So eventually what happens is this line, this bypass line, shuts off completely. All the temperature goes out to the tank or out to the system and returns back to it. If you do get a slug of cold water, let's say somebody's opened a cold radiant slab and you got a slug of cold water coming back, that element in here is going to sense that right away. It's going to reopen this port here. It's going to shut down this port and allow that boiler to come back up to temperature. So it's called a thermostatic mixing device, but it is a boiler return protection device. We offer it as a standalone without the pump on it here in a 1 inch and 1 1/4 inch version. So if you have to use a little larger pump, you know, this has got, I think, a star 16 pump on it, so you're limited to maybe a 10 gallon per minute flow. Let's say you've got a job where you need a 15, 18, 20 gallon per minute flow. You can buy the valve as a standalone piece and then put your own pump on it here. You can see real high CV on that valve, so we've got plenty of flow rate. We've got wide open ports in that. That is also available with a couple different temperature sensor cartridges in the bottom of there. So, and you can see it's piped in a two-pipe configuration here. So now we've got our load going out, we've got our buffer tank, we've got our thermal return protection all in a nice clean package here. That's the beauty of these here. It just takes all that guesswork and all the piping on the job site of. We just build it right in there. We give you temperature gauges to monitor, and so you know what's going on with that system. Cordwood boilers. Typically, you're going to see a lot larger buffer tank with a cordwood boiler because, like I say, once we get a fire going with cordwood, it's hard to stop that or hard to put that out, and we don't want to start dampering down the air going to that where we're getting inefficient or a smoldering burn in that. So once we load up a cordwood boiler, we want to burn that entire load that's in there until it burns out or until our load is satisfied. So with that in mind, we're looking at doing larger multiple tanks. So here's one way that you could pipe a couple of our thermocons together. And so there's our return protection device, there's our air elimination, and we've just put these tanks side by side, and with the thermocon, since we have all those large connections, we can do this little reverse return piping right here. So both of these are going to be loaded evenly, and then we're doing the same here, that we're taking our load off the upper side ports. We're just bringing our two side ports from the thermocon together, putting a large sized header here to make sure that we can cover the load here. So if you don't want to, or you can't find a large tank large enough to buffer it, this is one way that you could put the tanks together. And you could put multiple. You could put 2, 3, 4 tanks, as many as you want. We've got air elimination up here in addition to the Discal air separator, because we've got a dome top in there, so any little air bubbles that would collect on this after the pump shut off, that's an excellent place to get air out of a system, because that's the hottest point in the system. It's also a domed low flow velocity section in that tank. So, and then down here at the bottom, this is an example where you might have access to one large tank. I know some guys will sometimes use old LP tanks that they repurpose for these buffer tanks here. So same concept here. We just have one tank. We're going in with the thermal block as our, the thermal block becomes our boiler pump as well as our loading device here. So this one pump can do the loading for the tank, and it's got enough flow to go through the boiler. And then we would take our loads off either the side of this tank, or you could come off the top of this tank here. So just two different ways that you can buffer with multiple small tanks or one large tank. And this was something kind of interesting I saw when I was at one of the shows in Europe. And as I drive around Missouri where I live, I see these great big hay bales out in the, they bale the big round bales there. And I'm thinking, gosh, there's a lot of energy sitting around rotting away in these fields in a lot of cases. So I snapped some pictures of these, and I found some more online here. But these are big bale burners. You can either burn the smaller square bales, or some of them are large enough like this one here that you can just stick that whole bale in there. I would imagine you could probably get it, a few days to a week's worth of burn on a residential application with one of those big 800,000-pound round bales. And there's a number of companies in Europe as well as the U.S. Typically this is for ag applications where they've got access to this this hay that they can burn. All right, I want to talk about geo now. And geo to me is, again, loop fields. It could be in a well, it could be in a trench system, it could be in a pond or a lake. I know we've done some on the rivers and stuff around Wisconsin here, where they got permission to put some heat exchangers or loops out into the different streams and stuff. We did two different hydronics issues on that would give you some ideas on piping schematics and things. One was specific to geo-hydronic systems. We came out with issue number 9 here when we introduced our manifolds and some of the components I'll show you specifically for geo. And then we did one on hydronic cooling, which again is using chilled water instead of hot water to do some cooling loads and stuff like that. But it does have a lot of good piping information and some control logic in that in there. But let me show you what we've got here for a geo manifold. We make this available from 2 to 8 ports. You got up to about 24 gallon per minute flow rate through this. It's got a big, large ported out manifold here, temperature gauges, air vents on the supply and return. It does come built just like you see in the picture here. It's got nice stainless steel brackets, pre-punched, so you can just put some mounting in the wall and just hang this on the wall and then make your connections to it for your loop field. What's nice about doing it with a manifold like this is you've got the ability to add flow setters and flow meters on it. Our quick setters go on that. We've got fittings that you can connect to this without needing any fusion tools. So you can just have a compression fitting. You just bring in your loop connections here, put them right in that compression fitting and tighten them up. So it allows you to put in a loop field without having to have a lot of special equipment to hook up all that the PE tubing that's typically used for those loop fields. Down at the end here, we've got the valves, hose connections right there with a little shut-off valve. So if you want to pump your fluid, if you're going to pump glycol into this, you've got the ability to do that right there. And now if you put the manifold in with isolations or with quick setters on, what you can do is you can fill it up one loop at a time. So now you can shut off 2 loops, open this one. Now you can pump through, make sure you get all the air out, purge the air out off the bottom connection here, pump it in here, go on to the next one and the next one. I like to see this installed with our quick setters on here. We've got a quick setter that goes right onto that connection there, because now when you fire up your system, you've got the ability to see what your flow rates are. If this was designed to have a gallon per minute per loop and you fire it up and you don't have any indicator, if you don't have any flow meter in there, how do you know if this loop is still airlocked or if you're getting all the flow through it? So this gives you the ability to see what you've got on every loop. If you have to adjust them, for some reason one loop is longer than the other and you want to dial it in a little bit, now you've got the adjustability on the 132 quick setter to see what it is and also dial them in so you get the exact flow rate that's required by the design. It's also excellent for troubleshooting. I know there's geo systems out there that are underperforming because they've got some error problems in the loop field. How would you know that unless you have some kind of flow setter? So you can build it however you want. You can put the flow setters on. We've got the compression fittings. If you've got your own fitting that you want to go on to a connection, we can give you a threaded connection here also that you can build your own. We also give you these an option to buy these GeoCal fittings, and this is just a compression by compression elbow. So if you want to, instead of bending your loops as they come through the wall, we have a big arc here, which is putting some strain on your connections. Use an elbow like this, and now you've got a nice straight shot out the wall. You've got a nice straight shot up to the manifold. We do have what we call a GeoSeal. This is a little expandable rubber grommet, so to speak, and it's got some screws in it. So you drill through your concrete wall. If you've got a watertight seal that needs to be made there, instead of trying to smear that with a tar or some silicone or something like that, this little loop seal goes right in there. Your tube goes through the center of it, and you just take a nut driver and you tighten up these 4 screws. They're stainless steel screws, and it expands against the wall as well as against the tube. So now you've got another nice tight seal both against the tube as well as through the penetration through the wall. So take a look at these. They're modular. As you can see, we build them to whatever spec you need. So you tell us how many loops you have in your field, and we'll custom build this. We test it. We send it out in the box. It's got temperature gauges, so you can see what kind of performance you're getting from the loop field. This is a really nice way to put these systems together. I know the homeowners appreciate that they've got something that they can that they can see what's going on with their system and make sure that they're getting all the performance that they want or that they paid for out of their loop field. I thought this was a great idea over here. This is one of our contractors in Wisconsin that does loop fields, and he sends one of those camera drones up, and he documents where his loop fields are. So if ever somebody had to go in and find where this field was put in, or say, oh, how many loops did you put in there, or where's your loop field? This is part of his system and system documentation along with his piping and wiring schematics. He puts in a picture of this loop field, how it was put in there, and where it is on the lot and stuff like that. Kind of wish septic installers would have done that years ago. If you've ever had to go out and find a septic tank to pump it out, and out there with a probe for hours. All right, so I'll talk a little bit about buffering heat pumps. This is another application for a thermocon tank, because what we want to do with a heat pump is we want to run good long cycles on that. We don't want to short cycle this. We don't want this kicking on, running for a 3 or 5 minute, kicking off. That presents a lot of wear to the compressors and the pumps and all the components in it. So most of the time, the manufacturers of these heat pumps, whatever brand or whatever style you like, they're going to give you a formula how much buffer capacity they want based on the size of this unit. So if you've got a 5-ton, they might tell you, 2 gallons per ton or something like that, or 10 gallons per ton, whatever it might be. So that's what our intention here is, to just make sure that we're not short cycling our heat pumps. So thermocon can be used for chilled water. It's insulated all around. It's a foam line tank, so this could hold heated or chilled water, and we're just going to pipe right into that. We're going to put our air elimination device there. We've got the well in the center for their temperature probe, so you might drive this heat pump right from a temperature sensor well in the center of the tank. Air elimination at the top, a drain valve at the bottom. So that's what we want to do, is we'll charge this tank, and now ideally you want to pull the load off of this tank with a variable function here that could be based on outdoor reset as well as the load on the system. So let's say that's a variable delta P pump. As different zones kick on and off, this pump kicks up and down, ramps up and down just to match the load exactly, and then you would pull that load off this tank with an outdoor reset control. So on a shoulder season day, if it's, let's say 40 degrees outside, we don't need the full temperature out of this tank. We're just going to mix and modulate that tank temperature to exactly what the load needs. And we make different mixing blocks from Caleffi that we can put right out here on this manifold that could mix that temperature down. You could have multiple temperatures going out to different temperature requirement loads, high, mid, and low temperature applications. So we've got all the components to put these different systems together. If you're interested in renewable energy, John Siegenthaler, I think this is going to be out in January. It's, I think, 800 pages. He talks about the latest state-of-the-art equipment, different piping schematics that he'll have in there, different control logics and stuff like that. So if you're a fan of John Siegenthaler's stuff, this is going to be his latest offering as far as renewable energy specific projects. Let me see what I've got here for the last couple. As far as support, suppliers, we've got Caleffi product from across the country. We've got Alaska. We're all over. So that's the first place to go for information and for our products, is go to your supplier. Our reps can help you. We've got reps across the country that can help you with support, technical questions. Certainly you can call us here at Caleffi in Milwaukee, or call one of Jody or I. Were out on the road all the time, but we'll help you with designs and stuff like that. One other thing I want to mention here is we get a lot of questions and a lot of requests for help. What we don't offer, we can't help you with it. If we're not engineering, we're not going to do a design for you. We're not going to do a load calculation and tell you what boiler, what brand, or what type of pump and stuff like that. We're glad to help you with, conceptual drawings. If you want to send in something for us to look at and say, what products could you help us select here, size products like that. But we really aren't in a position that we can design systems for you or, help you with a complete application. There's engineers out there that specialize in renewable energy. We can certainly hook you up with that. I mean, Jody's full-time job is training engineers, so he knows where they are, and he knows people that specialize in these type of systems that can give you a hand if you need design help, or if you have to troubleshoot a system that you're having problems with. We'll certainly help you out there and steer you to. But really what we want to help you with is product applications. If you need a specific mixing valve or a balancing valve or air elimination, hydraulic separation, really every single product in our catalog works in renewable energy technology. I mean, we're talking about fluids here, we're talking about glycols or waters and stuff, so we've got a product that can help you out with anything. I've got a couple last housekeeping slides, and then I'll turn it over to Mark and see if there's any questions here. We talked a little bit of the Coffee with Caleffis are archived. This one will be up in a couple days on the website to have access to that. Hydronics, if you're not on our mailing list, by all means go to our website and sign up and make sure you get on board. If you need some back issues, the reps can help you with that. If not, let us know if there's something you're missing or somebody borrowed one of yours and didn't return it. We can help you fill that in. Number 18, typically we'll have that at the ASHRAE show, which is in Orlando at the end of January this year. Come down and see us at our booth there, and we'll show you some of the new stuff that we've got, and you can meet the crew. But Hydronics is probably one of the best tools. I think this is really a tool, not just a glossy thing that you get as a promo. There's a lifetime worth of information on all our Hydronics issues. So keep in touch with us. However you'd like to keep in touch, we're on all these different social media. We try and stay at the forefront of all this, and there's some of our smiling faces at the bottom there. Mark, anything there that I can talk about until the cows come home?
I'm sure you can, Bob. Yeah, a couple of questions. Back up to the geothermal application. You had a schematic up there. The question is, what type of antifreeze is typically used in the ground loops, and are there any antifreezes used that would be a problem with Caleffi components?
Yeah, and that's an excellent question, and that does vary from installer to installer. I know down in Missouri where I live, there's a lot of this going in. The terrain's just right for that, and there's a lot of them that have just regular water in them. As long as you can make sure that you've got this below frost level, that you can get into the basement of a building and you're in a spot where you can use just water, by all means, that's your best heat transfer mechanism. Glycols are common. The guys I talk to typically stay as low as they can, maybe a 35% glycol solution to give them a little extra protection. The more glycol you put, the more pumping requirement and the lesser heat transfer, so keep it as minimal as possible. There are some alcohol-based ones out there, methanol and ethanol systems. I'm not a big fan of that. It is a flammable product, and if you go to the people that manufacture this component right here, pumps, there's no place anywhere in their literature or their information that said that's been approved to pump a flammable liquid. So I know that makes them cringe a little bit when they hear methanol systems going in. But yeah, it's just going to be based on what the conditions that you're installing your loop field. And if you feel there's a potential for them to freeze, you certainly want to protect against that with either a glycol or there are the potassium fluids that have been used over the years. I think really the go-to fluid. There are geospecific glycols that are available out there, propylene glycols typically. So,
staying on this application, Bob, with some other questions. The earth loop field has an expansion tank connected to that air separator. What's the advantage? Do you need an expansion tank on the earth loop field?
Yeah, because I mean the fluid's going to change temperature in this, the heating and the cooling mode. If this is a heating and cooling application, we need an expansion tank in there when we heat fluids because they expand, but the opposite happens when we chilled water. So if we put, let's say, 10 pounds of system pressure in there and we chilled this, we started using this as a chiller and this loop field temperature started going down, the pressure is going to go down. So this expansion tank works both ways in a system. We want to have a little bit of reservoir and fluid in there so that as we start cooling this down, that we don't lose, people come in and say, oh, my gauge dropped down to 0. I must have lost fluid in the system somewhere. Well, no, you might have just, the water pressure went down as you chilled it. So this does work as both a, an expansion vessel as you're heating the fluid, as the temperature goes up, as well as having a little bit of storage as the water temperature goes down, that we don't see our gauge pressure going down to zero. So it does need to be sized for the application, for the amount of fluid that's in the system and the temperature differential that you're going to see, and this is how you would size and select that tank. So
another question came in on the other side of the heat pump there, the buffer tank, the heat storage tank. Any rules of thumb as to how big of a tank you would want in relationship to that heat pump or the load?
Yeah, and I would go to what the manufacturer of this component, the heat pump, they usually have, and the formula I've seen over the years is so many gallons per ton of this, and I don't want to quote a number because it might vary from brand to brand, but they'll typically tell you based on the the tonnage, the size of this unit, how many gallons of buffer they want. Again, it's just to keep the cycling out of this. So I would really probably defer to their information on what they tell you is a good size. I mean, you can't overdo it in my mind, other than the cost and of course the size of the tank as far as where you're going to get it in the room. But yeah, see what Climate Master, Water Furnace, or whatever brand you like to use on that. See what their information is for sizing this.
Very good. Another one jumps over to solar, and it's back on expansion tanks again. I don't know if you covered this, but are there any rules of thumb for sizing an expansion tank that's on a solar loop if I'm using a pump glycol system?
Yeah, and you know what? It's a little bit more involved than it is for a hydronic system, because if you think about it, we've got a big differential potential with a solar thermal. I mean, a day in the wintertime, that solar collector could be sitting up at the roof at, below freezing conditions, and if that sun comes up, we could see, a 200-degree temperature in the summer months. I think the stagnation temperature on our collector on an 85-degree ambient day, our collectors will stagnate about 344 degrees. So that's a lot of temperature differential. So what you'll find on solar tanks is you're going to have a much bigger tank than you would in a hydronic. And the formula that we show, I think it's in both those hydronics. I know it's in number 3 for sure. What it's going to do, it's going to take in, it asks you to break down the piping on the roof, on the collector, where you could see that 300 plus temperature, and separate it from the capacity of the system that's below, the collector, where you're not going to see that temperature, because it's going to be a huge tank if you sized it for 300 degree, a delta T for the entire fluid of that system. So the formula does get a little bit more complicated than it does for a hydronic system. I saw a website the other day that one of the tank manufacturers actually did have a solar thermal expansion tank sizer. I'm sorry, I don't remember which brand that was, but if you search around for solar thermal expansion tank sizers, there are some online calculators that you just put in your, the volume of your system, the type of fluid, the percentage of the glycol, and that'll help you size that. The math is pretty long, but if you need a hand with that, let us know. We do have the formula, longhand formula in our hydronics that we can help you size that. But yeah, you'll find it's going to be a bigger tank than you're typically used to in hydronics.
Sorry, we're jumping around here a little bit, Bob. But
no, that's good, because I'm glad you're queuing these up for me.
Yeah, another question. And were you looking to go up to the solar schematic, because it's another question on solar?
Yeah, let me find that one. On the piping schematic, maybe, or?
Right. Yeah, I think that's where it's at. Go back to, in sizing the storage tank, are there rules of thumb in terms of how large of a tank I want based on the number of collectors used?
Yeah, and it varies depending on where you are. I think the guys up here in Wisconsin look at like a gallon and a half of storage per square foot collector. The southern states, if you have higher gains down there, they might have a little bit more storage capacity, just knowing that in Phoenix you're probably going to get a little bit more gain than you are up here in Milwaukee. So it varies a little bit, but I've heard that number anywhere from 1 to 2 gallons per square foot of collector. Now, if you want to nail that in and get that exactly right, I mean, by all means, I would use one of the solar simulation programs like T-Sol or RETScreen or PolySun is another one. You can size that tank if you pick the location. You can get the weather data from the closest weather station to you, and you can put all the information in. What is the load? How many collectors am I thinking about using? And it'll size that tank for you based on the actual job that you're working on, as opposed to just a rule of thumb of saying 1 to 1.5 to 2. You can actually get that number from one of the solar simulation programs and get it exact.
Very good. Another question while you're on this one was in relationship to an air vent. If you put an air vent on top of a solar collector, is it to be left open or does it get closed off?
You know, that's an excellent question, and I know there's, you know, this is kind of like a Ford or a Chevy type of issue. Definitely leave that open when you first fill the system because any air and stuff's going to go up there. The one issue with this here is if there ever is a problem, you know, if it sticks or it leaks or something like that, it leaks down you know, the side of the roof and down the side of the building and stains the roof and stuff like that, and you lose some fluid. So I think years ago this was a common application to have one up on the roof because we didn't have these pumping stations where we had a safety group built into it. And what's unique about our solar pumping station here, I don't know if you can tell, but these two gauges actually have shut-off valves built into the gauge. So let's say somebody worked on this and they left these off and they went home and they forgot to turn these two valves on. If you didn't have a pressure relief valve up here, an air vent or something like that, this goes to steam and now you've pressurized the system. So sometimes you'll see an air vent and a pressure relief valve up here, but I'd like to just leave that open until I fill the system, you know, start it up, get it up to temperature maybe the first time, and then close that cap off. We do include an isolation valve in our packages right here, so some guys will say, you know, we don't like the looks of it up there, we don't want that sticking up on the roof, so they'll go back after you know, maybe a week or a couple days where the system's been running, make sure they've got it completely de-aerated. They'll shut that valve off and they'll take the vent out and take it with them. So you've got the isolation valve there, there's a cap on the vent if you want to shut it off with the cap and leave it on there. You've got a couple of different options, but it definitely helps you when you fill it up and when you first fire it up because, you know, until you start heating up that fluid, until the sun starts heating up that fluid, you don't get all the air driven out. And it's really hard to de-aerate glycol. I don't know if you've ever experienced that, but it's a lot tougher to get the air bubbles out of glycol than plain fluid. So it can take a little bit longer. It can take a couple days until that collector gets up to a high operating temperature that you've got all that air evacuated out of it. We do on our solar pump stations, there actually is a little air elimination device built in here, and I don't know if you can see it in this picture, but there's actually a little coin operated or a little screw operated air vent at the side of this, so when you go back to that, just open that, and any air that you've gotten trapped and pulled out of there, you can burp it out of this if that vent's been closed off on the roof. So there's a couple different ways that you can get air out and keep air out of the system with either the vent at the roof or the automatic air purger that's built inside here. This is a manual one, by the way. This isn't an automatic air vent that's open all the time. You have to physically go in there with a screwdriver, a little coin vent, and open it, get the air out, and then close it back off. This is an auto air vent up here with a float in it that can work on its own. And this does need to be a solar rated one because, again, you've got the potential to see 300 plus degrees up here, so don't just use a hydronic air vent up there and expect it to last very long. So this is included in our package. Again, everything in the grayscale here is in the package, but we do sell that as an individual component with a high temperature ball valve, by the way, also. So yeah, thanks.
Bob, we've gone after the hour, but we've only had about 8 people drop off, so there's a very high interest, obviously. So let's go another 5 minutes with questions. And
yeah,
anyone that wants to ask a question if we don't get to, please key them in, and we'll make sure we circle back around to you. So let's keep going here for a couple more minutes. Shall we, Bob?
Yeah, I'm
Maybe
okay.
the next question's up. Go up to the 2-tank system you showed earlier, because I think it's in regards to that.
Okay.
Okay. So the question is, if the first tank becomes fully heated,
yep,
and I have more solar energy than what it can store, does the controller allow me to send heat somewhere else?
Yeah, and that's a good question because that does and it will happen if your load goes away or the occupancy of the building changes or somebody else buys the home or the building and they're not using as much hot water as it was designed to provide. You're going to go into an overheating condition. And what we really don't want to do is overheat. If this is a closed-loop glycol system, we really don't want to overheat that glycol on a continuous basis. I mean, it can take a little bit. Typically, the solar glycol fluids, the HDs, are rated for 350 degree temperature, but we don't want to do that a lot because we'll start breaking it down. So inside our controller, which is this little part right down here, it can go right into the cover of our solar pump station. You can remote mount it. There's a couple different overheat protection functions in there. So What this controller can do is it'll watch the collector temperature. And let's say this thing turned off at noon. The tank got up to, let's say you had it set at 140 degrees, it got up to temperature, it shut off, the pump shut off, and now the collector's just sitting up on the roof and the sun's out and it's getting hotter and hotter and hotter. Well, this sensor up here is going to keep an eye on that temperature, and it's going to say, you know what, I think the factory default is 275 degrees. It's adjustable. Say, you know what, I got a lot of heat in here. I'm worried about the glycol being exposed to the high temperature. I'm just going to pulse that pump and turn that pump on for a period of time, and I'm going to just run that for 30 seconds, I think is the default on it. And I'm just going to flush all that glycol that's inside that collector out, and I'm going to send it down to the tank, even though the tank doesn't want it or says, you know, I've got enough. So it's going to do that until you get to a high limit on this tank temperature. Obviously, we don't want to take it over where the relief valve is going to pop. So it'll just keep pulsing a little bit of temperature in that, a little bit of temperature. And so what it's going to do, it's going to overshoot the temperature that you've got this tank set for. So let's say, for example, at the end of the day, this tank got up to 160 degrees because we went into what's called collector cooling mode, where we're just going to cool the collector. We're going to cool the collector. Every time it overheats to 275, we're going to just take a slug of fluid back up, wash that high temperature out. So now we've got a tank that's sitting at 160 degrees. Well, if nobody uses water during the evening hours and the next morning we've got a hot tank, we don't really want that, because now we're in the worst case scenario. We're going to kick on at 9 o'clock and we've already got a hot tank. So another function that's built into this control, and these you have to go in there and enable them, turn them on. The factory default is off, so you have to go and enable with this collector cooling. And the other one, I think it's changed. I think it's called system cooling now, SYC or OSY. I think it's option system cooling. And what you can do with a solar collector, again, this is a heat exchanger. Let's say this tank did get up to 160 degrees by the end of the day, and you don't want that the next morning. So what you can do with this control is you can allow this pump to run again at night, and you can actually take the temperature out of this tank back up to the collector after the sun goes down, and you can actually dump heat out of this tank back to out. Now, obviously, you're using energy to do that. You're kind of going the wrong way, but I can actually cool this tank almost down to ambient temperature. So let's say it's 80 degrees at night. I can run this pump until I get this tank back down to about 90 degrees. And now that what that'll do is the next morning, now you've got a tank sitting here at 90 degrees instead of 140 degrees. Now I've got the potential to harvest energy again without going into yet another overheat mode. Now, I'm a big fan of drain back systems. We didn't show any here because, you know, we've only got a limited amount of time. But if you've got a job where you expect to have an awkward load like that, or a load that goes away in the summertime, maybe it's a you know, you've put a lot of collectors on the roof to do some radiant heat load, but in the summer there's no load on it. What the drain back system will do, and we've got arrangements in our collectors for that, we've got some components for that, a pump station, is when the pump shuts off, all the water drains back out of the collector and the piping that's on the roof. So everything here above the roof line just drains out. So that really is a better way to protect systems where you're going to have that awkward or offset load like that, is to put a drain back. But just know that the control does have those functions. We've also got a provision in here that you could put a heat dump in it. And a heat dump could be a little blower outside, a little Modine type of heater. It could be a loop of one of your radiant zones. I know Bristol down in New Mexico will use one of his radiant loops as a dump zone inside the house. So if this tank gets too hot, he'll just kick on one of his radiant zones and dump some of the heat there. So, you know, you don't really want to dump heat, because that's heat that, quote unquote, was free energy that you got. And then if you're running a pump to get rid of it, you're kind of going the wrong way on your financials here. Running the pump to get rid of free heat doesn't pencil out so well. But yeah, so we can help you with that. If you do have a job where you've had problems with them overheat, your glycol's breaking down, we can talk you through how to enable those functions, how to set them up, how to use those. That can buy you a little bit of a wiggle room for overheat protection. With all of our controls have those functions in them, by the way. All right, well, yeah, thanks everybody, and we'll see you next year. Come down and see us at the HR show if you want to go down to Florida in January. That's a good time of the year. So come down and see us, and thanks everybody for your support, and happy holidays.